Saxon Advanced Mathematics, lesson 29. This is a trig lesson, and it's a cool one, although I'm going to postpone a lot of the coolness for later. So let me tell you about that. The first topic is called the unit circle. The unit circle is a really cool organizer that allows us to bring together a lot of the different information about trigonometry that we've been studying. Primarily sine, cosine, and tangent for our two special triangles, our 30, 60, 90 triangles and our 45, 45, 90 triangles. We're gonna put all of that information, and the signs, remember how we just learned the positive, negative signs and the different quadrants? We're gonna bring that into it, and we're gonna bring in some information that I'm giving you today. And I'm just gonna show you, this is a unit circle diagram without any of the information filled in yet, but I want you to see how it looks. And I'm gonna be sending you a link so that you can print your own copies of this. Notice how there is a plus sign buried in this, right? See, there's a basic grid. That is our same old Cartesian coordinate system, right? With the x-axis and the y-axis that we've been using forever. And we're going to talk more about that today. But these other lines represent, this is a 30, 60, 90 triangle. This is a 45-degree triangle. And this is a 60-degree angle. So this makes the other part of our 30, 60, 90 triangle. And notice that we've drawn the three basic reference triangles in each of the four quadrants of the graph. That's interesting. We'll get to that later. Don't let that hang you up too much. But that's what these lines represent, is a 30-degree angle, a 45, and a 60. And then for each of the quadrants, right? Filling in the same. So we already know a lot about those angles. We know how to figure out the sine and the cosine of those angles. We don't have to talk about it. Of course, there are an infinite number of other triangles that are hiding in here, but we don't worry about them because their numbers aren't as obvious. We can use a calculator if we ever need them, but we're gonna ignore all those other angles when we talk about the unit circle. Today, what I wanna talk about specifically is, I wanna talk about these angles, the angles that are at the dividing lines of the different quadrants. Okay, those are the ones we wanna talk about. Before we put all the information on here and fill it all in, I want to give you this last piece of the puzzle, this bit about the quadrantal angles. That's what these are called. And then after you have a week or two to get this all settled in your head, then we will tackle the project of filling in this chart and figuring out how to use it, okay? So John covers this today. It's too much. It's too much new to digest at once. It will make you sick. So we'll come back to this later. And that's all I'm going to say about the unit circle for today. What I want to talk about are what we call the quadrantal angles. And if you think of this as a little mini version of that unit circle I just showed you, right there's the plus sign in the middle. I'm not going to draw the other angles. And we're going to make it a circle. Pretend it's perfect. And we're going to say that this is exactly 1 unit out in every direction. Okay? So just like, you know how usually we put the little markers on? Well, this is really big. This is 1 unit out in every direction. Now, what we're going to do is we're going to talk about each of these angles, because even though this is a line, we can see this as an angle. So I'm going to start with, this is 0 degrees. This is 90 degrees. This is 180 degrees. And this is 270 degrees, right? So we're going to go through each of these 4 points one by one, and we're going to talk about the angle that lives right at that line. So let's start with the first one. I'm going to recopy the whole picture so you can see it. This is where we're talking about 0 degrees. Okay, so we're going to be discussing this specifically. And I want you to imagine that there's a little angle here. Now, obviously this isn't exactly 0 degrees, because if it was 0 degrees, it would be right on that line. It would be flat, right? But I'm making it just a tiny bit bigger so that we can see what we're doing. This would be the right angle. This would be the angle. This would be the adjacent side. This would be the opposite side. Let me make it say opposite. Adjacent. And this would be the hypotenuse here. Okay? So the adjacent side would be equal to 1. The opposite side would be equal to 0, because that would be squished, right? And this hypotenuse would also be equal to 1. So the sine of 0 degrees, right, which is right here, would be equal to, let's see, it's Oscar had, right? So it would be the opposite 0 over the hypotenuse 1. So the sine would be 0. Okay, so the sine of 0 degrees is 0. It's sort of satisfying. What about the cosine of 0 degrees? That is the adjacent over the hypotenuse, and that is 1 over 1, right? Adjacent is 1, hypotenuse is 1. Oh, so the cosine of 0 degrees is 1. Now let's do the tangent of 0 degrees. That is over Arthur, and that is the opposite side is 0, and the adjacent side is 1, so the tangent simplifies to 0 also. All right, well now what we're going to do is we're going to make a summary of all the different values up here. So we'll start with 0 degrees, and we'll write sine is 0, cosine is 1, tangent is also 0. Okay, so these are the values of the 3 basic trig functions at 0 degrees. Now let's go and do 90 degrees, right? And we're going to work our way around the circle. And it'll get a little faster as we feel a little more comfortable. Ready? So I'm going to draw another basic circle, and we're going to imagine what it would look like if we squeezed an angle really close to 90 degrees. Not quite there, right? We would draw it back down to here, and we would see that from here, the adjacent side would be 0, the opposite side would be 1, and the hypotenuse would be 1. Do you see how I'm sort of able to imagine that? If I imagine that tiny little triangle squished in here, I imagine this side is approaching 0, so I'm calling it 0. And I'm 1 unit up, so both the opposite side and the hypotenuse are pretty much equal to 1. That's how I'm doing this little calculation. This is again at 90 degrees. Okay, so the sine of 90 degrees equals Oscar had equals opposite is 1. Hypotenuse is 1. So sine at 90 degrees is 1. How about cosine? That's a hold. The adjacent side is 0. The hypotenuse is 1, but that equals 0. That's the opposite of what we had before, isn't it? Let's try the tangent of 90 degrees. That's over Arthur. Opposite is 1. Adjacent is 0. Uh-oh, there goes the kingdom. That can't happen. So what we say is that the tangent of 90 degrees is undefined. Right? Because that is trouble. So 1, 0, undefined. Let's go add that to our list. 90 degrees, I'm gonna put it up here. Sine is 1, cosine is 0, and tangent is undefined. And that is the information about our 90-degree quadrantal angle. All right, so we're seeing some interesting shifts, right? Sine goes from 0 to 1, cosine goes from 1 to 0, tangent goes from 0 to undefined. That's kind of weird, isn't it? Okay, let's see what's happening over at 180. And just to move this along, I'm going to choose a different color. And let's draw an angle here. Again, we're pretending that it's exactly at 180 degrees, but we're drawing it just a little bit off from the line so that we can see what the triangle would look like. Okay, again, here my adjacent side is equal to 1. My hypotenuse is equal to 1. But here, my opposite side, that's going to equal 0, right? That's the part that's just being squished down to nothing. So for sine of 180 degrees, again, it's Oscar had. Opposite is 0. Hypotenuse is 1. So the sine of 180 degrees is 0. Cosine of 180 degrees equals a hold. Adjacent is 1, hypotenuse is 1. And tangent at 180 degrees equals 0 over 1, which is okay, right? We can have a 1 on the bottom. That's just a plain 0 as our final answer. So now I'm going to copy these over to this, and this is sine equals 0, cosine equals 1, tangent equals 0. There are values at 180, and look, the values at 180, oh wait, I'm wrong on one thing that I need to say. Cosine in this quarter is negative, right? Remember this chart? I need to take these values into account. Okay, so they're a little bit different because we're not right in the quadrant, but I can see here the side of this is -1, isn't it? 90 degrees, I'm still in the positives because this is +1. But over here, my adjacent side is -1. So this answer is actually -1. So I need to reflect that right here. Cosine is -1. So that's the only difference. It switched from +1 to -1, but the other guys are zeros. Now let's do the 270. And those answers will be in orange. The triangle looks like this, right? So our opposite side equals now the angle's here. So it's always so crazy to think about. The opposite side from this angle is -1, the adjacent side, oh, I drew it wrong, that's why. It would be like this. The opposite side is -1. The adjacent side is 0. And the hypotenuse equals 1. If your brain's starting to scramble, just trust me, all right? This will make more sense as we go. So at 270, it's -1 over 1, so sine equals -1. We don't really need this chart as much as we just need to get the values right on here. Cosine of 270 equals adjacent over hypotenuse equals 0 over 1 equals 0. And then the tangent at 270 equals over Arthur. So that's -1 over 0. Uh-oh, there's undefined again. Okay, so let's take this back to our original chart here. It will be sine equals -1, cosine equals 0, and tangent equals undefined again. Right, so that's at 270. 270s are in orange. And the 180s are in blue, just to help you see the colors. So look at the pattern that's happening here. Sine goes from 0 to 1 to 0 to -1. Cosine goes from 1 to 0 to -1 to 0. And tangent goes 0, undefined, 0, undefined. What is helpful at this point is to make a chart that summarizes these values in a simpler form, because this is kind of cluttery. So this is kind of the theory as to showing how all this was developed. Now I'm going to show you a simpler way to remember them. We need 4 rows, and we need 5 columns. Okay, 4 by 5. Our rows are called sine, cosine, and tangent. Our degrees, our columns, are the 4 different quadrantal angles. I know this seems weird, and right now you're probably like, I'm completely lost. Trust me, it's going to make sense as we start doing problems a little bit more. All right, we now know the sine, cosine, and tangent at 4 other angles, right? We already know 30 degrees, 60 degrees, and 45 degrees because we memorized those triangles. Now we're going to memorize these 4 angles in addition. And what we figured out was that this is the pattern that sine makes, right? I could go back and look at my notes, right? 0, 1, 0, -1. 0, 1, 0, -1. Cosine does something else. It starts with 1, and it goes like that, right? 1, 0, -1, 0. Beautiful. And then tangent is the weirdo, right? Tangent starts at 0, and then it goes to undefined, and then it goes back to 0, and then it goes to undefined again. All right? So that's what UND stands for, is undefined. This is what I want you to memorize now. We don't have to worry about the big circle. We're going to come back to that later. I want you just to memorize this chart as well as this thing that we talked about last week. This information as well as our two triangles. That, and then this other guy. 1, 2, square root of 3, 30, 60, and 90. All of this information is going to be brought together, and we're going to keep track of it all in one place on this unit circle. But before, it's all this information. You already know all the information. We're just going to reorganize it into one big diagram. But before we do that, I want you to just get a little bit more comfortable with using them in the separate pieces that we have before we put it all in together. All right? So when we get to that unit circle, just remember, it's all this just coming together in one big happy trig party. You know that book, Go Dog Go, Dr. Seuss? I bet you read it or learned to read. My kids all learned to read with that book. This is like the big dog party in the tree at the end, right? You know, where they have the cake and they've got scooters up there and the tutor horns and they're juggling and riding unicycles. It's like everything's going on in one crazy happy treetop. That's what our unit circle is going to be. This is our Go Dog Go party. All right, so we will come back to that later after you've had a chance to digest this for a hot minute. Now, let's practice using this information in problems, and I think you'll see, okay, I can handle this. Example 29.1. We're supposed to, it says draw the figures necessary to find 3 tangent of 180. I don't want you to worry about drawing the figures. I want you just to see how simple this is. It's just like our other problems. We start by finding the tangent of 180, and then we're going to multiply it by 3. How do you find the tangent of 180? Right now, all you have to do is look right here. 180 degrees tangent. It's 0. So this is 3 times 0, which equals 0. Okay? That's super easy. Now, if we wanted to draw the diagrams, I will walk you through that. 180 degrees is over here, right? Right? 90, 180. And if we were drawing an itsy bitsy little triangle to a point really close to 180, we'd draw it like that, wouldn't we? And the side of this leg would be pretty much -1, and the side of this leg would be 0, and the hypotenuse would be +1, because it always is. This would be the hypotenuse. This would be the adjacent side, right? And this would be the opposite side over here. And that would be equal to 0. Tangent equals, over Arthur, the opposite side is 0, the adjacent side is -1, but either way, that comes down to 0. And this is the same 0 that we got here just by reading it off the chart, okay? So what I mostly want you to do is trust the chart, but remember that you can draw the pictures if need be, all right? Next one. (29.2). Draw figures as necessary to find, oh, and he does an A and a B thing. John, he's so underhanded. 4 times the sine of 270 degrees, and then B is 3 times the tangent of 270 degrees. Now, again, we're going to rely on our chart. We are not going to worry about the diagrams at first, right? I want you to solve it first and then draw the pictures. The sine of 270, okay, I've got another copy of my chart right here. The sine at 270 degrees is minus 1. So this would be 4 times minus 1 equals minus 4. And that's the right answer. Tangent at 270, uh-oh, it's undefined. So forget about multiplying it. We just write undefined. Once we determine this much is undefined, we're done, right? Once the universe blows up, there's not much more. How can we multiply that by 3, right? Okay, now we'll just quickly review again how to draw the picture. 270 degrees is the down one, right? So we're not exactly at the end, but we're imagining a point that's really close to it. So it'd be like this, right? And so if that's our angle, we know our hypotenuse is 1. Our adjacent side is 0. I forgot to write hypotenuse. And our opposite side, right? Opposite is always associated with the y. Our opposite side is also very close. I'm going to put OPP so it's not looks like a 0. Our opposite side is also 1. So when we're trying to find the sine of 270 degrees, that would be Oscar had. Opposite is 1. Oh, it would be negative 1, right? Because it's going down over the hypotenuse. So it would be negative 1. And that is exactly what we have here. And then for the tangent of 270, it's over Arthur. It would be minus 1 over 0. Oopsie. There's our undefined again, which is what we had right there, right? That was undefined. Okay? So you can trust the table, but I want you also to feel comfortable drawing the pictures if need be. Now we just have one more, and this time we don't have to draw the pictures. It says evaluate the sine of minus 135 degrees plus 3 square root of 2 times the cosine of 180 degrees. Whoa, holy cow. Okay, now the first thing I'm thinking about is quadrantal angles. 0, 90, 180, 270. This is not one of the quadrantal angles, right? But this one is 180. So I'm going to do this one first. I'm going to pay attention to it. So I'm going to go to my chart and I'm going to find out, here I'll slide up a little bit. I'm going to find out the cosine at 180 degrees is negative 1. All right, so this is 3 square root of 2 times negative 1, which is minus 3 square root of 2. Now I'm going to combine it with whatever I get over here. Minus 135 degrees, I better figure out what that is, right? So let's see, if I'm going backwards, because it's a minus, I'm going to go 90 and then another 45. Okay, so I think I'm in the third quadrant, like this, right? Because this is 90, this is 45. That gives me my minus 135 degrees this way. And that leaves, since it's 45 taken out of the third quadrant, this is also a 45. That means it's 1 square root of 2. Now I can find the sine of that. Sine is Oscar had. Opposite is 1. Hypotenuse is square root of 2. So, and let's see, I'm in this quadrant. So this would be, let's make my chart, I'll make it here. Plus, 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 minus, plus, minus. Sine in the third quarter is the top one, it's minus. So this is minus. Now I can't, this is too squished, so let me do it. This part equals minus 1 over the square root of 2 minus 3 square root of 2. Okay, so now all I have to do is simplify this, right? This is equal to this. There's where I calculated it. There's my picture. This is equal to that. I just multiplied it by minus 1. And I got that off my chart. We're at cosine of 180 is minus 1. So that's how I got that minus 1. I'm going to bring this to the top of the next page, and all we have to do is a little bit of algebra to clean it up. All right. The first most annoying thing I see is this. So I want to rationalize that. Like so. That will give me minus square root of 2 over plane 2 minus 3 square root of 2. Okay, there's no equal sign, so I can't make the denominator go away, but I'm going to have to make them match, aren't I? So this 3, I'm going to have to multiply this by 2 over 2 to get the bottom. I multiply the wolves, not the pigs. Minus square root of 2 over 2 minus 6 square root of 2. There's the 6 over 2. Now I remember there's an invisible 1 here. So minus 1 minus 6 equals minus 7 square root of 2 over 2. That is our final answer. And that's correct. Now, what did we even do? What does any of that mean? Well, what we did was we found the trig functions, the ratios of these two different angles. For some reason, we multiplied that one by 3 square root of 2. We don't know why. Now, why would you want to do this? Why would you want to find the ratios of sides at two different angles, multiply this one by that, and then add them together? Why would you want to do that? We don't know. We don't know. But when you get to calculus and engineering world, then you'll know. Then this will all start to make sense. Right now, we don't have a greater purpose in mind. We're just practicing the calculations. All right? So, I think that's all. Yeah, 29.3. That is the end of this lesson. So I just want to put you back to this page. Let me cover this up. I want you to really work on memorizing these 4 pieces of information that we've been looking at. These 2 we've looked at, these go back to last year. These 2 are new, okay? So make sure all 4 of these are pretty solidly mushed into your head. Practice them, right? Just randomly, if you're sitting in the car waiting for your sister's piano lessons to be done or whatever, just grab a piece of paper and start doodling and see if you can remember them. Post them on the refrigerator, on your bathroom mirror, near the window that you stand and stare out of when you're bored with your life. Wherever you will notice them, it's really just helpful to have them around where you'll look at them, okay? So make sure that you're getting those memorized because like I said, in another week or 2, we're gonna put all that information on here and see what happens from there. Okay, yay, lesson 29 is done. Thank you, goodbye.